In section 2.3, we're going to review some properties of lines. First, we're going to review the concept of slope. The slope of a line that passes through 2 points for which we know the coordinates of, and we label those coordinates as x sub 1, y sub 1, and x sub 2, y sub 2, is given by the following formula. M for slope is equal to the change in y divided by the change in x, otherwise known as rise divided by run. Now, rise is simply the difference between the two y coordinates for the points that we know to be on the line. And run is known as the change in the y coordinates for the 2 points that we know to be on the line. The slope is synonymous with incline or steepness of the line. And we can use any 2 points on the line. We only need 2 of them, but it could be any 2 points whatsoever that fall on the line. Here in this diagram, we see 2 points. Let me go ahead and make them a little darker. They will have some coordinates. One will have x1 and y1 as its coordinates. The other one will have x2 and y2 as its coordinates. Remember that the subscripts are simply a way for us to keep track of which is point 1 and which is point 2. Now, the steepness of the line is the same, regardless of which point we identify as point 1 and which one we identify as point 2. So the subscripts can be reversed as long as we have the x and the y coordinates stay together for each point. Let's go ahead and practice using the slope formula to find the slope of a line that passes through the points 8, 4 and 8, -1. So as we saw up atop, m is equal to the change in the y coordinates, so that'll be -1 minus 4, and the change in the x coordinates, so that will be 8 minus 8. So we get -5 divided by 0, which is a problem because division by 0 is not defined. That means that the slope of this line is undefined. Undefined is not a number, so don't mistake it to be the same as 0. It simply means that we attempted to divide by 0, and that is not a defined operation. We're going to see later on in this section what type of line would pass through points in such a way that the slope is undefined. If you want a little sneak peek, that means that this is a vertical line, and we'll see more of that later. In the next example, we have the points -4, 3 and -8, 2. Let's find the slope of this line. Again, we're going to subtract the y coordinates, so 2 minus 3, and we're going to subtract the x coordinates, -8 minus a -4. So we get -1 as the numerator, and in the denominator we get -8 plus 4. So we'll get -1 divided by -4, which simplifies to positive 1/4. I want to show you that if we had subtracted in the opposite order, we would have gotten the same result. So in the calculation above, I treated -8, 2 as the second point. And now I'm going to treat -4, 3 as the second point. So in the numerator, we're going to subtract 3 minus 2. In the denominator, we'll do -4 minus a -8. Now we get 1 as the numerator and -4 plus 8 as the denominator. So we get 1 over 4. Which matches, okay, exactly the same slope as we got previously, but we just interchanged which one was the first point and which one was the second point. Next, let's find the slope of the line that passes through the point 1, 8 and 8, 8. In this case, we have 8 minus 8 in the numerator, and then we have 8 minus 1 in the denominator. That is 0 over 7, which simplifies to just 0. Again, we'll talk about this a little later in this video, but this is a special line as well. Whereas a line that has undefined slope, we will see, is a vertical line. Lines that have zero slope are going to be horizontal lines. Okay, let's keep going. Next, we have two lines that are already graphed for us, and we have to find the slope of the line. Certainly, one way to do that is to identify 2 points that fall on the line and use those x and y coordinates to substitute into the slope formula. But there's an alternate way to find slope. We can simply track the movement from one point to another. You just have to choose 2 different points, any 2 you want. In this example, we have the following 2 points selected for us. Here we have -4, -5. And the second point that is darkened for us has coordinates -3, 1. Rather than using the slope formula, let's track the movement from one point to the other. First, we would have to travel up 1, 2, 3, 4, 5, 6 units up. And then we would travel 1 unit to the right. So that movement of 6 up and 1 right can be written as the slope is +6 for the numerator and +1 for the denominator. So 6 up is the y movement, 1 to the right is the x movement. So of course that would simplify to just 6. Let's calculate this using the slope formula to show that we get exactly the same result. Now, it doesn't matter which point you use as the starting point and which one is the ending point. After all, they are on the same line and the line has the same slope throughout, the same steepness, the same incline. In the next example, we're going to travel from the top point to the bottom point to show you that it doesn't matter which point you use as the origin and which point you use as the destination. I shouldn't have used the word origin because that has a very specific meaning here. I should have said the starting point and the ending point, just to be clear. So in this case, we're going to start with this point and travel downward. Let's track that movement. We would have to go down 1, 2, 3, 4, 5, 6 units down, and then 1, 2, 3, 4, 5, 6 units to the right. So 6 down, and then 6 right. That means that our slope would be -6 for the numerator, because that's negative y movement, and +6 for the denominator, because that is positive x movement. This simplifies to -1. Now, just to show you get the same result, let's move from the first point on the bottom up to the point at the top. The movement there would have been 1, 2, 3, 4, 5, 6 units up, and 1, 2, 3, 4, 5, 6 units left. In that case, we would have gotten the same result. Oh, my pencil's giving me a little bit of a hard time. We would have had the same result, and it's not letting me write anymore. Let me go ahead and pause here, and we'll pick up in the next video. But again, we get the same slope regardless of which direction we travel.